Welcome to EDU World Space.
Here, we'd like to know which p-values make this series convergent. So this is a rough-looking sum here, so let's try to use the integral test. So here I would look at the function f of x. So just replace all the n's with x's. So here, if you take any x larger than or equal to 3, then this will imply that x, ln x, and then ln x also are all positive. And you can check, go to the calculator and see that's the smallest value of ln, because once x increases, this also increases. So this double log also increases as x increases. Okay, so that guarantees that f of x is non-negative, part of the integral test requirement. Also, we need that f of x is decreasing. Now, the easiest way to see this is that as x gets larger, all these terms in the denominator also get larger. Another way to see this would more difficult, but you could compute the derivative and then show it's negative if x is bigger than or equal to 3. That's another way. Now we're in a condition, since these two are satisfied, these are the hypotheses for the integral test. So those are satisfied. So that means instead of looking at the sum, we can look at the following. Natural log of 3 to infinity. And then now we have f of x. And what's the best way to compute this? There's probably several ways, but perhaps the easiest substitution here that one could make would just be to take u to be the double log. Because if we do this term here in the bottom just becomes u to the p. And also, if you take the derivative, differential here, and use the chain rule, then you get the remaining part of the integrand. So there was a little typo up here. Let me go back and change this. I did not do the substitution at this point, so that lower bound should have just been a 3. Then after the u sub here, now we have because right here that's an x value, but now we have to use the corresponding u value, and the way to do that is you take the x lower bound, plug it into the u sub, and then that new value becomes your new lower bound. And the same could be said for the upper bound infinity, because if you take the limit here as x goes to infinity, that also goes to infinity. So now we're just left over with 1 over up, and by the p-test, this converges if and only if p is bigger than 1. So therefore, by integral test, we conclude that our series converges if and only if p is larger than 1.